You guys see my screen?
Yes, we can, Doctor.
Okay. So what we did previously, actually, for this topic 4, Logic Gate Boolean Algebra Part 1, students are asked to watch the previous lecture, 2021 lecture, its complete version about this topic for Logic Gates and Boolean Algebra Part 1. Then I do the pre-lecture series with students, testing what is the gate that they know, and what is the logic symbols and Boolean equation, truth table, and trimming diagram. So indirectly, we have learned them. And then what we didn't learn yet is that the for the single variable theorem. Okay, I don't want to repeat everything that have been repeated by my 2021 previous lecture. Otherwise, it will be very long for the student. You need to watch many video and it's longer. That's why things that have been touched my previous lecture, I won't touch it again. Okay, so just feel free to watch the lecture video. You have the complete version actually. Okay. So we go for the NOT gate, gate with more than two inputs, okay? NAND gate, NOR gate, NOR gate equivalent circuits, okay? This one is if we have the symbol with this, okay, plus with circle means that is exclusive, okay? Exclusive. Whether it is exclusive or exclusive NOR, okay? If it's exclusive NOR, you just have inverted here. X NOR, N not, okay? Previous one, X or A exclusive B, exclusive or B, okay? If X no, you have N not inverter, so you have the inverter symbol on the upper part, okay? So this one also have been touched in previous lecture about the propagation delay. You won't get an ideal response, okay? You won't get an ideal response. Okay, so you will get, for example, if in ideal case, okay, if you have input like this, for example, then the corresponding output can be anything, but maybe like this, for example, corresponding output, for example, okay. But in real life, in practical, we don't have this. Whatever change in the input will be directly in the change of output. No, actually there will be delay because this circuit, right? We have propagation delay for signal from one logic gate to one logic gate is traveling, you know. So we have some delay. Okay. So that's why this is not. This one is the ideal case, but for the practical case, maybe there will be a bit delay. Okay, let's say this is your input. Okay, this is your output for ideal, and this is your output for the practical case. Okay, maybe there will be a bit delay. Okay, and so on. So delay. This is this is the delay, and then we have learned about this one. Um, wait, why I cannot? Oh, okay, no, this one. Wait, what is happening? Why I cannot? Why I cannot? Wait, this one. No. Wait, sorry. Okay, now okay. So we have this time, okay? Time for changing from the high to low, okay? Here, from high to low, this is the time, okay? And then this is the time for lagging from low to high, okay? So you can see there is also time here, okay? The time delay, propagation delay. So this is time from low to high, and this time is from high to low. Okay, so T, P, low to high, Okay, and this one is TP high to low. Okay, so this one I ask you guys try. Okay, at your own. Okay, this one is quite easy. Whether you want to do from this side or you want to do from this side in order to get the equation. Okay, for example, if you want to do from this side, you will get F equals to, then you go here. Okay, because it's OR, so you have, if you start from this side, you will have 1, 2. Okay, you have three things that will be OR, will be 8. So first one is A plus B, AB. Second is B bar, C bar. And the third one will be A and C. Okay, so overview of digital circuits. Okay, this one have been shared it also in the previous lecture, in my lecture that I already record for you guys. Okay. Okay, now we go to this one. This one have not been touched, but already been touched by my previous lecture. So I don't want to do many things repeated, otherwise it will be longer for you. Okay, so there is one thing about this single variable theorem. The word already justified means it is a single variable. We only have one variable, whether we have A, whether we have B, but it's only single variable, and only A, for example, or B. You cannot have more than one. So because this means like single variable. Okay, single. So for this one is n form. This one is for O form. Okay. O form, n form is actually multiply, and O form is actually plus. So A annulment is that it's being null. Okay. Whatever times by 0, you will still have 0. Identity is that we learn from the mathematics, additional mathematics. Identity is that we get the same number back. Okay. So just like this, A times 1, we will get the same number back, the same variable back, which is A. And then we have idempotency is that different than what we learn in mathematics, right? If we have A times A, you will have A square. Okay. But in digital electronics, no. A times A, you get A, not A square. Okay, but A. Complement, okay, whatever A times A inverted will give 0. Because if you have A is 1, for example, and A plus A bar is actually 1 plus 1 bar. Okay, which is 1, 0, and you get 0. So that's why it's always 0. And then involution is that if you have double bar here, for example, A, okay, this one will be like cancel out, you will get the same A back. Okay. For the OR form, okay, A plus 1, regardless of what value of A, if we plus with 1, we still have 1. Okay. The same for A plus 0. Okay, similarly, A plus 0 contradictory, 0 have no effect, so A will be translated as the output. Okay, A plus A, the same like in the n case. For if we in the mathematics A plus A is equals to A, but in digital electronics, no, it's A plus A, you will get this A. Okay, and A plus A bar equals to 1. Why? If you have A is equals to 1, A plus A bar equals to 1 plus 1, 0, use 1 plus 0, you get 1. Okay, so this is quite direct. Okay, you can learn it from my previous lecture and also my module. Okay, it's quite straightforward. Okay, this is I think this one has been touched my 2021 previous lecture. Please watch it. Previous lecture part 2. Okay, this one. Okay, but it's already inside the uh I'm not sure if I already put in e-learning or not. Wait. But I did remind you guys through Telegram because I have no energy to open this and that yesterday before coming to class. I put here in case that you want to, so that you have the full list of what you should know and should learn inside the e-learning. Okay. That's why my e-learning should be able to show this as well. Okay. Okay, he's here. Okay. So it's already here. Please watch the exam before coming to class. Okay. So this is identity theorem. How they actually get it? A times 1 will get the A. Okay. This one is have been explained by my previous lecture. Okay. This is actually how we prove the concept that we learned in the single variable theorem. How we prove it in terms of logic gates. For example, identity theorem. And identity means everything that we times by it, we get the same things back. Okay. So A times 1, you get A. Okay. So A times 1, you get A. So you see what is the same zero, the same as the input 0, 0. Okay. If the output is 0, the input is 0. And if the output is 1, the input is 1. So this one is related to the identity theorem. Okay. Regardless, and then you can see the B is always 1. Okay. So this is the one. Okay. And then for the OR case, A plus 0 equals to A. So you see there is always 0 for the B, this one. And then regardless of value of A, the output will be the same as input. So 0, 0, and 1, 1. So this is how you explain in the logic gates. I think this is quite self-explanatory. If you don't understand, please ask. Okay. So finish with that. Okay. Single variable theorem. The last part uh, of the topic 4. Okay. I will share this later. I think I already shared it. Okay. I already shared just now. This one. You guys can check it. Okay. Now we go to the next one, which is topic 5. Topic 5. Topic 5, logic gates and Boolean algebra part 2. Anyway, before we start, I will give group assignment again. Group exercise. Group exercise number 2. This one will cover the remaining of the number system, 2.9 something, and the rest at the back. And also we cover the logic gates and Boolean algebra. Okay, which is later. Later I will give. I want you guys to do the exercise more, although it's a lot for my class, because I don't want you to, when the test come or when my quiz come, okay, you will be shocked if you don't do the exercise. So for group exercise 2, it will be later on. I will give the 3.1 until 3.4, page 40, and also 2.9 until 2.13, excluding 2.11. Okay, page 30. Yeah, I think that's it. Okay. I think that's it. Okay, this one is for group exercise 2. Okay, group exercise 3 later on is on logic gates and Boolean algebra. So I will release the same name list, the same group, just the change of leader only change the leader. Okay, so later on I will update it today. So now we continue with topic 5, logic gates and Boolean algebra. Is actually a standard version of what we learned in topic 4. Okay, so in overview is that so multivariable theorems, we will learn about commutation, association, distribution, and De Morgan's. This one have been covered in my 2021 previous lecture also on part 2. Okay, multivariable means we have more than one variable. Okay, we have more than one means we can have A, B, we can have A, B, C, and we can have more. Okay. Okay, De Morgan's theorem form of expression, we have sum of products. Wait. Okay, so we have De Morgan's theorem. Okay, De Morgan's theorem is that, for example, sorry, I'm being disturbed by admin WhatsApp. Okay, so multivariable theorem is we can have A, B, C. If at least it is more than one, it is considered multivariable. This one has been explained inside by my 2031 previous lecture. In fact, it is more complete if you see that. And then simplification theorem. Okay, this one is we want to simplify the theorem. Either we can use uniting, adsorption, consensus, or multiplying. Then we go for the De Morgan's theorem is that A plus B equals to AB and so on. Okay, De Morgan's theorem. We'll go to that later. And then form of expression, SOP and POS. This one is sum of products. Okay, this one is product of sum. Okay, what does it mean by sum of product? Is that we have a product, sum, we put in sum of product. So sum of products. Okay, inside can be A times B times C, A times B times D, for something like that. And product of sum is a product of sum. Product of sum. Okay, inside can be A plus B plus C, D plus B plus A, something like that. Okay, and then describing logic circuits, analysis of logic circuit, and minterm and maxterm. Okay, I think I will go to particularly on this minterm and maxterm because the rest here have been explained by my 2021 previous lecture. The same thing, I don't want to repeat, otherwise your video will be longer. For you to learn even become longer if I repeat the same thing. And then logic simplification using Boolean algebra. So this one have been learned in the 2021 lecture video. Okay, please watch it in case if you didn't watch it yet. Okay. Okay, this one. Okay. I put the link already, e-learning. Okay. So theorem, we have commutation, association, distribution, De Morgan's theorem. Okay, what is actually more interesting or more maybe you need to well versed is one of them is De Morgan's. De Morgan's. In De Morgan's theorem is that A times B inverted will become A inverted multiplied by B inverted. We call this sometimes the inverted is bar. So A bar dot B bar. Okay. Bar AB equals to bar A plus bar B. Okay. So for the commutation theorems, you can see A times B or B times A still result in the same thing. So this is commutations. Okay. This is for the AND gate. Okay. For the AND gate. For the OR gate, A times B or B times A will still result in the same thing. Okay. Multi-variable association, this one is associates. So whether you use, for example, if you want to use AND circuit, this one is the single AND gate. A times B times C is equals to A times B and then A times B times C. It's the same thing. Okay. Or you can start with B times C and then multiply with A. So it's the same thing. Okay. Okay. So association is the same. This one is for the AND gate and this one is for the OR gate. They are the same. So whether A plus B plus C is the same as A plus B in bracket B plus C. So it's the same. So this is association. Okay, this is the simplification theorem. You need to practice max perfect. This one is more likely like, for example, if you want to do your admit, okay, additional mathematics about theorem, about trigonometry. You need to practice in such a way that you will be able to answer lah. Okay, I put some my 2021 previous lecture have discussed about this. Okay, for uh, for example, how you obtain things like this. Okay, for example, I don't want to repeat this one. This one I just do some summarization. Okay, for example, absorption here. Absorption here. You have A plus AB. You can factorize A, then you get 1 plus B. Regardless what is B, this still result in 1 plus B. So that's why A sorry. This why is A here. Okay. Sorry, I thought this. Okay. So it's become 1, then it is A. Okay. Regardless of what value of B, because this still result in 1. Okay. How about this one? This one is absorption. This one is adsorption. Okay. If A plus A bar B. Okay. So how is get to A plus B? A plus A bar B, A goes to A plus B. So, wait. Okay. A, B plus B bar plus A. There is no right or wrong. I mean, you can have many way to solve the question and to get it. Okay. Okay. AB plus A B bar. Wait. What I'm doing here. Wait. So absorption here A plus A bar B. I'm thinking how to make it even simpler. A plus B. A plus B. A plus A bar plus A bar B. AA plus AA plus A bar B. I think it's, wait, I think it's, there is no right and wrong. This one, I mean, at least when you get the answer, it is correct. There are many ways. Even I'm thinking this one, the way A plus A can also, you can also B plus B bar plus A bar B. AB plus AB bar plus A bar B until you get the AB bar AB B A plus A bar plus A B bar B plus A B bar. Okay. What is happening here? Sorry. Maybe my mind not work correctly. Sorry, maybe my mind not work correctly. They should be, you should get the same answer. Okay, what is happening with me right now? Actually, I'm should be taking leave today. Okay, never mind. Wait, I try first. I want to try. A plus absorption A plus A bar B A plus B. A plus A bar B. Anyone know how to solve it? You can teach me and teach the class. I don't know whether what happened to my mind. This one is actually should be easy. What? A B plus B bar. B plus B bar plus A bar B should be B plus A B bar plus A bar B. Okay. So this one is this one A bar B is one zero one zero. Okay. I'm lazy already. Okay, can you please check at my 2021 previous lecture? I don't know what is happening to me. Okay. This one shouldn't be problem, but I don't know what happened to me. Okay. So sorry. Okay, please see this at my 2021 previous lecture. Okay. Or maybe you guys know how to solve it. Anyone? Anyone know how to solve it? I think my mind is not correct. This is what happened when like sick lecturer trying to teach. Even try to teach. Okay. This one, please look at my previous lecture. Okay. Thank you, Mohammed. I will look at it. Means page 42, not 40. Okay. For the assignment, right? Group exercise. So this one already covered in my 2021 previous lecture. Okay. I am sorry what happened to me. Okay. Okay. I'm sorry. So please watch at my previous lecture. I have do on that. Okay. I have food poisoning yesterday and today, even though I not yet, I have no longer vomit and diarrhea, but my body still feel a bit weak. Even sometimes a bit blur. I don't know. Okay. Okay. So this one is absorption. Okay, absorption. Please look at my 2021. I already touched on this. Okay, I don't know what happened to me. Okay, this one is multiplying. Okay, this one is just simply like what you did in your maths, or mathematics. A plus B, A plus C. Okay, then expand. A, expand again, plus AC, expand again. A bar B, expand again, BC. Okay. So A times inverted A will result in 0 plus AC plus A dot B plus BC. Okay. BC AC A dot B. A dot A bar plus
Doctor, then you put beside BT 1.
apa?
Tadi doktor buat betul dah. Lepas tu
Yang ni ke?
doktor tak atur. Dia jadi, bukan.
Yang ni ke? Multiplying ni ke? Betul lah
Yang tadi jadi kosong.
Ah,
Lepas tu AC plus A bar B plus BC and then bracket 1.
plus BC bracket 1. Bracket 1 B ni ke?
Sebelah BC. 1 tu dia jadi A plus A bar.
Oh, okay. Ada dalam video saya kan?
Ada.
Okay, thank you means no Diana have watched the video. I am sorry you guys. I don't know what happened to my mind. Oh my god. Okay, so this one BC I expand. Okay, in my lecture video, I expand them. AC plus A bar B plus BC. Then this one will be expand. A plus A bar. Betul tak, Diana? This one is it? Okay. So then
Yang
solve.
A tu 0.
Then solve at the end dapat this one, right? Okay.
Dapat AC plus A bar B.
Okay, good. So actually, actually, 8 April is my birthday, so I go eating with my friend. Shell out, Then I eat. I think shell out. The seafood is not clean, so I have food poisoning. You know, seafood. If you don't cook properly, you have food poisoning. So I have food poisoning. Yesterday memang teruk lah. I keep vomiting. I think 10 to 15 times. Vomiting, and diarrhea is more. Like 4 to 5 times. So so that's why. Oh my god. Okay. Things that I already solved last time, I forget already. Okay. Okay. So this one, please watch my 2021 lectures. If you don't understand, please let me know. Okay. Even my mind not work correctly now. Okay. So have been covered. This one is okay. De Morgan's theorem is what we. Yeah, my birthday is if if you guys notice, okay, if you guys notice, my this video week 4 Gates and Boolean Algebra part 2 is on 8 April 2021. 2021. Then we have lecture today 8 April. Lecture today 10 April. Okay, so dekat-dekat lah, close to my birthday. Okay, never mind. Okay, thank you. Okay, so useful for, okay, this one is De Morgan's theorem. Okay, De Morgan's theorem is that if you want to solve problem involving inverted variable, okay, so we can have, first is we can have this A dot B inverted, but if you want to split it, it will become A plus B plus. A inverted plus B inverted. Okay. Similarly, if we want to go for the OR, so A inverted OR, okay, you will have A, this one. So this theorem is very useful. This theorem is very useful in case you want to solve for inverted variable. Okay, wait. 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 I want to show you this one. I want no. Yesterday. Wait, this one. Yesterday. Where am I? Yesterday. Yes, yesterday. Yesterday I am at clinic. Okay. Okay. So that's why sorry okay. So this one is if we want to do proving, okay? If we want to do proving, um this is exercise you can try to do. For example, here is proof A plus AB equals to A. Okay, you try this first. If I try now, maybe I will not give you the right answer. I don't know what happened to my head. Okay, A plus A bar B. Okay, for example, this one you try to prove and you should be getting this. Okay, you try first. You try first. Okay, I will share the slide today. Okay. Okay. Now what is more important is actually min-term and max-term. Okay, because this one not really covered by my previous lecture. Okay. Okay, convert to simplification procedures. Okay, now we want to do the simplification procedures. Okay, so simplification procedure is that we want to simplify. We want to simplify from the more elaborative form to the simple one. So first is that we convert to S or P sum of product form. Okay, for example, if you have A plus B times C plus D. So this is sum of product. So what you do is that you directly expand it. Just what I do. Okay, AC plus AD plus BC plus BD. You directly expand them. Okay, and then you check for exact duplicate and drop. For example, if there is any exact duplicates. Okay, for example, this one AB plus BC plus AB, you drop AB. Okay, because A bar B there is 2. Okay, the things that duplicate you drop it because it's still the same. For example, okay. For example, if you have A B bar plus A B bar plus A B bar, you have 3, but you just drop the duplicates. It still become A B bar. Okay, so that's why it's mentioned here. You drop the duplicate and then you check for the full null value and drop. Okay, for example, you have A bar plus B. If you extend it, this one will result in 0. So you only have AB. Okay, so this is simplification procedure. And then another one, see if one of the item is entirely contained in another. If it's it, factor it out. For example, if you have AB plus ABC, you see the common one is AB, right? The common one AB. So you make a bracket. So AB equals to 1 plus C. Okay. So you have AB 1 plus C, regardless of what value of C, you still have value of 1. So that's why AB times 1 and A then result in AB, the final answer. See if two of the terms are different by only a not function. If it is, factor out all the similar terms. So you have ABC plus ABC bar equals to AB C plus C bar AB. Okay. So if two of the terms are different by only a not function, for example here, okay, you factor out the AB, then you have C plus C bar, and you know by the theorem, for example, A plus A inverted, you will still have one value. So that's why AB times 1 you have with AB as the final one. Okay. This one you can try at home. Okay, simplify. First you extend. Am I going to try this with my not so good mind right now? Okay, so this one you just extend xx plus xy bar plus yx plus y bar plus z. Okay, you can see this one is 0. What else 0? Okay, no. Okay, so then you have xx plus xy bar plus yx plus z. Okay, and then what else you can do is okay, x plus x. This one x can be put one another later on. Yx plus z. So this one you factor out x 1 plus y bar plus yx plus z. Okay. This one regardless of y, you still have value of 1. This one x plus yx plus z. Okay. And then factor out x, you have 1 plus y plus z. Okay. Regardless of y, value, you still have it as 1. So x plus z. Okay. So the final answer is x plus z. Okay. Oh, my mind's working correctly this time. Okay. Okay. So the answer is x. What is the answer just now? X plus z. Okay, I put the answer directly, so that you guys can try and see the answer, get the answer, the same answer. Okay, and then simplify this as well. Okay, this is you can do expand first. You can do the expand first if you want. Okay. Okay. First for this, we don't have C, right? We can expand first A, B, C plus C bar plus. This one you don't have A, so you don't have B, so you can have B plus B bar, A bar C. BC you don't have A, so you can have BC, A plus A bar. Then you extend A, B, C plus A, B, C bar plus A bar B, C plus A bar B bar C plus A, B, C plus A, B, C. Okay. Then this and this look the same. This one and this one look the same, so ignore. Okay, because this one and this one is the same, and then ABC is also the same. Hmm. Okay. So this one, okay, for example, this one, you can try to imagine first, okay? You can try to imagine. Okay. Equal 0, 0, 0, 1, 1, 0, 1, 1. Okay. If 1, if 0, 0, okay, if we have 0, 0, this means that 1 times 1 become 1. 0 times 1, it will be 0. 0 times 1 will be 0, and this one will be 0. Okay. Wait. Am I missing something? Okay. So if you see this, if we have AB, this 0, it will result in a 1. If you have AB 1, it will result in a 0. Okay, inverted. And if we have mixture, it will result in 0. Never mind. I try this and I will give you the answer later. I don't know what happened to me. I will give the answer later. This one. I will provide the answer. Hey. Simple thing also not working my mind now. Answer will be provided.
So,
Yes?
I have question for
Yes?
for this question. Just now you do.
Sorry?
I want to see your solution just now.
Oh, yes, this one?
Yeah. How about the A bar B C for the second line there?
This one?
The A bar
Yes.
B C got 2 1, right? Got 2
Which
1,
one?
1
One,
2
two, three, four,
3.
5, or 6? Okay, 3, okay.
Do you write down in the third line?
Sorry, 3, 4. You want, what you mean to say is
3,
3 and 4, is it?
number
3,
3.
4. Yes? Yes?
You write down in the third line.
Right now in third line, I didn't write it.
Didn't.
I forget to write, is it?
Ah,
Oh. Thank you. Oh, I don't know what happened to my mind. That's why I say I will provide it later. Okay. Okay. So actually, wait. Okay. Thank you, Joey. So means that where's the actually I cancel all my meetings today. Uh, all. Only I don't cancel you guys for 2 until 4. Because I think if I cancel too many things and keep on extending class, replacement class. But I cancel all, even your class 2 and 10 until 11. Okay, so uh, A, B, C plus A, B, C bar plus A bar B, C plus A bar B, C. Am I correct, Joey, this one?
yes.
Okay. Very funny lah me. Okay, okay. So then you can have okay, you can see this one A B bar, A B bar. Okay, what else? A bar B C, A bar B. Okay. A bar C, B plus B bar. Okay. Then this one is A B C plus C bar. Okay. So for here, regardless of what value of C, because we have inverted, so it is actually equals to 1. Okay, plus A bar C. And here, regardless of what value of B, because we have B plus B bar, so it is 1. So you have A, B plus A bar C. Okay, so this is the simplified one. Okay, so the answer is A, B bar plus, okay. So the answer is AB plus AC bar. AB plus AC bar. Okay. So another way we want to create, we want to write the inverted is this, okay, because I don't have bar item right now. Okay, I can, this is the same, okay. Okay, I hope you guys understand. This one means the bar, okay, the same thing. I can wait, or maybe I can just put it here. But it's two ways of okay, cannot. Okay, so this is the same thing, means also it is a bar. Okay, so form of expression. Okay, basic rule, connected gates form a logic network. An output can be connected to one or more inputs. An input can only be connected to one output. Most common is an or no. Okay, so this one is basic rule. Connect gates form a logic network. So network of logic gate means not only one gate, but a network of logic gates. And an output can be connected to one or more inputs. So you can only have an output, but it can have more than one inputs. Okay, you can have okay. So an output can be connected to one or more input. For example, if you have this, okay. So you can have more than one inputs, okay. An input can only be connected to one output, okay. Here, input can connected to one output, and most common is AND OR network. So AND OR network is that you can have AND OR network. For example, AND, then you have OR network. Okay. Two form of expression we have sum of products or product of sum. Okay, sum of products is that what I told just now. Sum of products means sum, okay, and then of products. Okay, can be A dot B dot C, A dot B dot C, something like that. And you have product of sum, product of sum. Okay, so what is sum of product? Sum of product is that product and sum or get. So this is sum of product. Okay, product of sum is that we have product of sum. Okay, so OR gate and AND gate. This one AND gate and OR gate. Okay. Okay, convert A to, oh, okay, this one you guys can try. Okay, first you see this is product of sum to SOP. Okay, you see product of sum, product and sum inside. AC plus BC to its SOP equivalent. So what you should do is that you expand the form until like this, AB, ACB, BC, and this one. And this one is resulted in 0, right? So this is your N SOP. Okay, you can try this from the other way around. Okay, try at your own whether you can get this one. Okay, you should be able to get it. Next is sum of product to product of sum. Sum of product to product of sum. So sum of product, this one is sum of product. So AB is the product. So sum of product AB bar plus BC bar to its post equivalent, means product of sum. So okay, so we have AB. Okay, so what you should do is that we put the inverter first. Okay, we put the inverter. Okay, then from De Morgan's theorem, if we break this, this become multiple. This become multiply, right? So A multiply this one. And then De Morgan's theorem, we apply again. This one can be further broken into plus. Okay, and we know that if we have double bar, means it will be the same as the original variable, which is B, for example, for this case. So A bar plus B, B bar plus C. Okay, and then you expand. You expand, then you should get this answer. Okay, but it is a F bar. Okay, the question is asking about F. Okay, then I think they should give you the more answer. Okay, then you have F equals to F bar. Okay, F equals to F bar. So when you already solve for this, then you see that F equals to F, the bar here, then you bar it again. You will get the same answer. The answer that you solve for F bar, then you put the bar again. Okay, I think there is a bit wrong here. It's in the slide. Okay, this one should be double bar. Okay, this one should be double bar because this one is you solve for F bar, and then in order to have the same number back, you should have double bar. This one should be double bar. Okay, double bar. Okay, please take note. This one should be double bar. How I'm going to write this? I hope you understand what I'm trying to say, because this one should be F double bar. Do you guys understand what I'm saying? Because this one we solve for F bar. Okay. I don't know how they put it. Maybe they use this one. How they put this one? Oh, wait. I'm lazy like this. Better I just put this one. Okay. So this one is F bar. F M bar. Okay. Copy. Paste. Okay. Okay, and then this one should be this one is also wrong. That's why you still need lecturer for the slide, because slide is also, even though it's the one that prepare is human, so it's possible that it is wrong. So this one should be bar lah, in order to get the same original back. Okay, now it's better. Okay. Why is it different? Okay, so now should be okay. Okay, now describing logic circuit algebraically. Okay, rules to build AND OR network. It can be OR or AND network. Okay, each AND operation require AND gate, one AND gate. Okay, each OR operation require one OR gate, and each complement variable requires a NOT gate. This one is actually understandable. If you have AND operation, you will use AND gate. If OR operation or sum, you will have to use OR gate. If complemented is also like inverted. Okay, inverted variable requires a NOT gate. Okay. Okay. Describing logic circuit algebraically. Okay. So what we have three variable here. Three variable. This one is describe. Okay, so you have three variable, which is a, b, c, and then how many product term you have? 1, 2, 3, and 4. Okay, 4 product terms, and then 10 literal. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you have 10 literal. Literal is like this one is 1 literal. Okay, this one is 2 literal. This one is 3, and so on. Okay. For example, this one is A, B bar, C, A bar, B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 literals. Okay, here. Okay, a literal is a variable or the complement of variable. Recall from part. Okay, so we go directly to the okay. So literal a variable or its complement. Okay, so literal cause the number of literal appearance in Boolean expression corresponding to the logic circuit diagram. Okay, so literal is a variable or its complement. Okay, it's considered as a literal. Where is the literal? Okay. So this is complement, a variable with bar over it. So you have A bar, B bar, and C. Literal is variable or its complement. This one is 1 literal, this one is 2, and so on. Implicant is product of literal. Okay, product of literal, which is this one is implicant, A, B, C bar. Okay, and then we have min terms and max term. Okay, min term and max term we will cover maybe today. I'm not sure. Okay, we see on the slides later on. Okay. Step for analyzing a circuit. Okay, the input to all gates must have a variable names. Write the expression performed by each gate at its output. Do it from left to right. The output of the last gate is in the network equation. So for example, this one is actually you just need to describe individually. I think this one is not that difficult. Okay, for example, okay, here you have initially is A, going through this will be A bar, A inverted B. Okay, then this one will be B, and then this one will be A, and this one will be C, and then A C you can C, A bar B, A bar B, you will have this, and then this is your OR. Okay, the results. Okay, I think if you do the module exercise, you become more well versed. Okay. And then the truth table, we have gone through the truth table last time. Okay. For example, if you have A, B, C, 0, 0, 0, 0, 0, 1, 0, 1, 0 until 1, 1, 1. Okay. Then you see here, this is the equation that given for the truth table. So you can use like this, you can separate like this, or you can use F directly. Depends on you. Okay. This one you can use this or not, depends on you. Okay. So for the first one is that A bar B, 0, 1 times 0, 0, and then plus AC, A plus C, so it is 0. Okay. The next one, A0, B0, C1. So A0, A0, 1 is 1, 0 bar 1, and then B is still 0. Then A times C is still 0, 0. So you can try this until this one. Okay. You can use this. You can put this in between here if you want, so that it will be more clear. Or you can use instant like me. Okay. The same thing. Okay. So next is okay, next, okay, you can okay, we can rest 5 minutes. You go to toilet, whatever. Okay, we continue at 3:25. Okay. Okay. So you can go to toilet, whatever. We continue at 3:25. Can you guys imagine? Today birthday, tomorrow food poisoning. Oh my god. Because my friend want to celebrate my birthday lah. So he belanja makan lah. Belanja makan at kedai seafood. Tapi have you guys, you know, if seafood, I think we need to be careful because we don't know how well it is cooked. Actually, that seafood shop is not a low quality restaurant. It's actually very high quality, but I don't know. Uh, ah, oh, my dad also good for. I think the seafood itself actually is not that it's not that clean. People get it from the, you know, the slot, macam lumpur, and then get it from the the ocean. And sometimes if the ocean is polluted, we get the toxic directly to our system. Okay, so that is what happened to me yesterday. Diana, do you your father diarrhea dengan vomit juga lah kan?
Yes.
Hmm. I didn't make a report because maybe I will make a report. Maybe I will make a report because both of my friend also get a diarrhea, but his response is a bit lag. He only experienced today 5:30 a.m. plus. I already experienced yesterday. Yes, seafood is very delicious. I think I will make. I think I will complain. I think I will complain because, oh my god. You can see, even though I think I can teach today, but still when I teach, many things I blur. Luckily, I have 2031 lecture to show to you guys. Okay, my healthy side. Last time, the healthy Raimi teach in 2031 is better than today. The food is worth it, nampak sedap lah. Tetapi, kejap ya. I want to show the food. Do you see this Facebook? This is my Facebook lah. Okay, this is my Facebook. So this is the you see this one? Is it look delicious? This one is the who knows look delicious, but who knows, right? Nampak delicious sekali tengok. Looks delicious, but who knows? Then actually I have stomach ache. This one. Shell out at the morso. The morso. I think I will complain to this. The morso. Also, this is cake. Okay. This one is from the Mama Sap lah. I get it. My friend sent. Okay. But this one who will thought that look like this food poisoning. Be careful to all of you if you want to if you intend to eat seafood. Actually that is I didn't eat shell out for so long. My previous shell out is last year only one time. Then I only take it this year. Then poor thing I get the food poisoning. This one, this shop. The morso. I'm not sure if you guys know or not this shop. So this is me before food poisoning. Okay, another 3 minutes we will continue the class. Okay. Luckily, you guys watched the 2021 lecture and you able to comment me. Means you have watched it and you able to correct me, which is good. Which is good. Means that you not only watch my lecture just like you watch movie. Just like you watch, you going to cinema and watch. Means you have watched my previous lecture. Okay. I don't want to waste my time so much on things that I already repeated. Otherwise, it become longer for you. So we wait for another 2 minutes. Maybe some people still at the toilet. Today I will have breakfast. Okay, buka puasa. I will have breakfast iftar with my student. With 3 of my student academic advisor. Do you guys have your own academic advisor? You should have already, right? Who is your academic advisor? Doctor, I still haven't got my module yet. Shopee lagging my order for a week already. Okay. Dr. Zahran. Okay. I think I will share the pages of the module that you should do for group exercise 2, and then I will share the answer. Not the answer, the back page answer means you guys need to have the same answer lah. Okay? Or Dr. Zahran. Okay. I will breakfast with my three of my academic advisor student. Okay? They are inside UTM right now. 3 of them. 2 boys, 1 girl. So I will eat with them. The deadline for what? Osama? The exercise, is it? Oh, group exercise, don't worry. I will give you ample time, okay? I will give you ample time. If I give it today, maybe Thursday or Friday need to pass. Is it okay? Thursday or Friday lah. Friday. Okay? I think Friday lah. Actually, exercise is actually just for me to like force you. To force you to do the work so that you will learn. Something like that. Okay? Uh, my quiz, is it difficult for those that didn't attend the class last time? Yes, because last week I asked the student, is it difficult? And some say not bad, some say difficult. For those that didn't attend last time, what do you think about my quiz? Is it difficult? For those that didn't attend the lecture on 7 April, super hard. Okay, super hard. Only for Ahmed, for the rest is easy. Okay. Okay, actually that quiz one, okay. Actually, that quiz one is that we have some question equivalent to quiz difficulty, and then I put some, but not all. I put some which is test question and final question. So if you're able to answer that, that is good. Means because some of the question inside quiz is actually test question and final exam question, but not the same. Means I modify it a bit. But the difficulty is the same. So if you're able to answer the question, it's good for your test and final. Okay. So please expect the same thing for quiz 2 as well. Quiz 2 maybe I will inform when is the quiz 2, but quiz 2 maybe whatever from topic 3 and topic 4. Okay. So prepare yourself for quiz 2, which is topic 3 and topic 4. I'm not sure when I will give it. Maybe next week, because we want to have 6 quiz, right? We want to have 6 quiz. So maybe prepare yourself. Maybe on 22 Friday. Maybe 22 on Thursday. Oh, Mark I will give. Okay. It's on 20. Maybe the next 21. 21 of 4 will be quiz 2, topic 3 and 4. Okay, and maybe again 6 to 11:59 p.m. Okay, this one. Okay, I will give just always see e-learning. I will update the mark at e-learning. Okay. Okay, so so we continue. Share. Share. Okay, where is it? Okay, now we go to what and why canonical form. This one has been touched inside my previous lecture. Let me see whether I have.
Create videos for your business.
I should install a blog. Not yet.
With hundreds of templates designed to get them
Faster. Assalamualaikum. Oh, okay. So I will. Okay, maybe I will stop before this, because you can watch here combinational logic network. Oh, okay, canonical. Oh, no need, Okay, so I will ask you to watch this. Means we will finish before. Okay. So here, what and why canonical form, and min and max term. Min term for 2 variable function. Min term for 3 variable function. Canonical SOP. Canonical form from non-canonical SOP, and this. Okay, we will continue this on the second day of the lecture, which is on Wednesday. But I will ask you to watch this first. Okay, I will ask you to watch this first. This one. Okay, because this is the one. Okay, and then for the tutorial, Okay, for the tutorial, wait for a while. For the tutorial, maybe you can do before the class. Okay, where is it? So, wait, individual exercise, group exercise. No. Wait, I will give you exercise for you to do for before the tutorial. Wait. Because for the first year, you guys are first year need to have more. We have more tutorial. Maybe in your senior year, the subject in senior year doesn't have tutorial. Okay, so I will give this. Okay, please check your after this class, after 4. Okay, after 4, please check. So this will be your tutorial. Okay, this will be your tutorial. Means you need to do before. When is our next class? I think it's on Monday. Is it? When is our next class? I on Wednesday, right? The next class. When is it? Anyone can check the schedule. When is the next class? On Wednesday, am I correct? Tuesday? We have class on Tuesday or Wednesday? Wait. Oh, Wednesday. 2 to 4. 2 to 4. Okay. So I will give you this. Please check it e-learning. Please check e-learning. I will give you this as your tutorial. Just do individually. Okay. And then the group exercise, I will give it to you, and maybe you need to submit. Don't worry. Maybe on 15. Okay. Group exercise. Okay. This one not many. This one is for tutorial only. Okay. Okay, with that we finish the class, and please check e-learning at 4 p.m. Okay, I will be updating after the class. Okay, thank you.
Thank you, Dr.
Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Okay.